All right, so I guess we can get started. Welcome, everyone. Today I'm going to be talking about automated accessibility tooling, hype versus reality. So we're going to be going into the different types of automated tools that are out there and try to disambiguate what claims are hype about what they can cover and what's the reality of what they can cover. But before we get into that, just a little bit of background about me. My name is Nick. I graduated from the University of Michigan in 2023 with bachelor's in computer science and linguistics. My focus before it was accessibility in undergrad was actually artificial intelligence. And then I pivoted because I didn't like that and wanted to work in accessibility instead. But that means that I know a little bit about, we'll have some slides later. I promise it's not going to be another one of the many AI talks that are scheduled for this conference. It's just the end of the whole thing. I interned at the American Foundation for the Blind. Absolutely loved it there. If you have any people that are asking about internships to help get computer science students into the accessibility space, they have a great program that every year is just getting better and better, where it's just bootstrapping basically kids who know nothing about accessibility but know a lot about tech, how to get into accessibility tech. So it's very cool, very fun. Had a great time there. I work at Assistive Labs. Right now, I've been working there since 2023. And yeah, we make accessibility testing tools. We have a cloud service for live testing. So if you're on a Mac, you can test NVDA and stuff like that would be on Windows only in the browser. I live in Boston. I love espresso and lattes. I like to play guitar and drums. And I forgot to put this up here, but I got into accessibility because my dad is blind. So I kind of grew up around screen readers. And it was a big part of my introduction to technology in general. So it really influenced what I was hoping to work on when I got older. So the agenda for today, we're going to be talking about the benefits of automation in general, not just from an accessibility lens, the tech stack for accessibility tooling, and where the different tools that are available fall on that tech stack. We'll be defining these tools, what they can cover, what they're good at, what they exactly do technically. We'll go through some example issues, and we'll see kind of like put these tools against each other and try to guess which could cover the issue. And it's not going to be an exhaustive list, but it'll be helpful for highlighting some key common issues that some tools can cover and some tools can't cover, and some issues that can be covered by pretty much everything. And then we'll have some takeaways. I did update my slides last night, like just a little anxious trying to get everything prepared. So if you've downloaded them before, you can download the latest ones there. So yeah. This is also a bit of a technical talk about kind of what these tools are doing. So if at any point you have a question or you want to ask something, please feel free to just raise your hand, interrupt, and yes, Lewis.
The mic.
And wait for the mic,
Please
yes.
wait for the mic.
The mic is necessary for the Zoom participants. Hi, everyone on Zoom. All right. Totally, yes. I didn't know that the mic, I feel like every time I've heard the mic, it's not echoing enough. Yeah. Oh, okay, yeah. Oh, that makes sense. That's awesome. Nice. That's great. Wonderful. All right. So let's jump right into it. Automation. So why do we want automation? Well, first, before we get to that, let's talk about the difference between automatic and automated tools. I think this is an important distinction because it's pretty relevant for kind of putting these tools into different buckets for what they actually are doing. And they kind of get mixed up a lot in the industry. This is not like a definitive, like this is what you would look up in a dictionary and find this, but I think that this is a pretty representative example of these kind of definitions and how they're used. So automatic tools are tools that work by themselves out of the box. You just take them and point them at your website or your application, and you'll get feedback, you'll get data, you'll get issues that they think that the tool thinks are there. They have built-in self-acting behavior that are developed by teams to try to find issues. So this would be like Axe, Core, Wave, Scan, anything that's basically got the word scan in it, it's going to be one of these automatic tools that will find issues. So an example would be an automatic Axe scan of the homepage revealed XYZ. So that would be an automatic testing tool. Automated tools are where it gets a little more complicated because these are tools that are set up to do a specific task when they're triggered. So they're configured by a human to validate like specific criteria. Anyone who's worked in like CI/CD pipelines knows that when you're deploying your code and you've like made changes and it's getting put on the internet, before it gets put on the internet, you want to make sure like at the very least this works. At the very least, you can make sure that this the API call is able to be rendered. There's things that you want to make sure every single time before you make a change to what's out in the world that nothing is broken, that you have all these things that you had before, they keep existing moving forward. So these are configured to just make sure that they're run, like you write them at one point, and then they are able to do the same thing over and over again very quickly at scale. So this would be an automated run from CI/CD revealed that the checkout flow is broken. So you made a change to the checkout flow, and now if you the checkout button doesn't actually, like the API call for that is broken. That would be an automated testing tool test or something. Do you have any questions about that? Or okay. So the benefits of automation in general are that it's fast. Computers can do things that humans just can't do. They can scan thousands of pages in seconds. They can run through interactions at the speed of milliseconds rather than, they can go really, really quick through tests that would take a human a long time to do manually. You get a really early feedback loop when you're using automation. You get some like pre-commit or CI failures, which I was talking about, that would stop a bug before they're shipped. So you can find out if you're making a change that's going to cause an issue. They're consistent. They're programmed to be mostly deterministic. AI is kind of changing that. But at a baseline, automation is deterministic. So you will always get the same result, except for Flake. Flake is something that people are trying to solve. You're supposed to always get the same result for an automated or automatic test if you showed it the exact same input. They're scalable, so it's a lot cheaper to apply to entire orgs than manual audits. If you were to add an ACK scan to every page on your website, that's cheaper than getting someone to manually audit every page on your website. Of course, I'll talk about the reasons that would not be the best coverage tool, but it's cheaper. It's cheaper to do at scale, and it gives you some easily documented data. So running tests at every build can document some good quantitative data about what your accessibility maturity is over time, how issues have appeared and disappeared, and what hopefully your graph in issues is going down. That's a useful thing you can get with automation, is you get all this data very easily, and it's kind of built in for free if you have data metrics being caught. And it's cheaper, usually. It depends on the tools. Some of these fancy schmancy tools get pretty expensive. So let's talk about hype and controversy. I know that some of these quotes I have up here that I'll talk through are quotes from the industry that are meant to inspire, automation is this wonderful tool that's going to change accessibility and allows us to do all these great things. And I took this first quote I actually hadn't seen before. I found in Adrian's blog post after the second quote was announced. But the first quote is, "Our vision is to make the entire internet fully accessible to people with disabilities by 2025, Accessibility Overlay Company in 2021. And that sounds like a great vision. That's a wonderful vision, right? But if you look through the rest of that, vision page that it was on this overlay company, they were explaining that this was going to happen because of their automation and their overlays and their ability to make the website just more accessible easily. And the second quote on here is from a recent accessibility conference where a vendor claimed, "Well, today I am telling you that I and everyone at this company is committed to achieving 100% automation, or so close to the difference won't matter for digital accessibility testing in the very near future." And they, on the next slide, had a graph of a timeline that had 2025 as the date that they listed 100% accessibility coverage, which is just crazy. We're in 2025. We're not there. We don't have 100% accessibility coverage. Anyone who's working in the accessibility space knows that you still have work to do on Monday. You have issues to solve. So that's a known fact. And there have been the point of this is not to say that these companies are bad for making these crazy claims. It's that they are trying to sell their ability to cover tools. And it's important for all of us as accessibility engineers, experts, advocates to have really fine-tuned bullshit detectors. You have to be able to know when someone is telling you something that doesn't exist yet. That's not possible right now. And it's really dangerous to those who don't know, because it's a complex, as I'll get into it, it's a complex space. There's a lot of different tools and features of the tools that disabled users are using that interact with each other and cause the issues and cause different things. So it's difficult to know exactly when someone claims something, what is real and what isn't. But hopefully part of this talk is to try to highlight, give you some information so you can better understand what is in the realm of possibility for tools and what isn't. And yeah, so that's some of the recent hype in automation and some of the dangers that it presents to the community. So what do these claims even mean? Adrian had a wonderful blog post about what does X% of issues mean. A lot of companies will say, oh, well, we can cover, 30% of X issues, or that's, they'll say some number, and are 30% of WCAG. And does that mean that you're talking about 30% of success criteria? Does that mean that you're talking about 30% of all of the issues that could be found on the website? Are you talking about 30% of the unique issues that exist in the world? It's really unclear. It's unclear. So ignoring all of these overeager claims from the last slide, most people say that automation can catch around 30% of issues, as I was saying, but it's not really clear what that means. There's not a good amount of data out there as to what the tools can catch and what is available. And people are great at creating inaccessible code. People are great at making weird, complex, custom UI components that have a new way of breaking accessibility. So I don't know if there's ever going to be a way that we can claim 100% accessibility coverage. Someone's going to find some way to do something crazy. But the point of this is that it's unclear what the percentage is when people are even talking about the numbers that they do have that are less than 100%. If you're talking about 30%, it's not clear what that means. And I would recommend reading Adrian's article to get a better explanation of this issue. And yeah, so moving forward. Another thing about why automation is important to understand the distinctions between what tools can and can't cover. The testing is complicated. Let's go through a bit of how the tech stack exists for a person who is using a screen reader accessing a website. So we'll start with the source code. So some developers at a company created the website, and they wrote the website using a framework like React, or using just raw HTML and CSS. And the website exists now either bundled as this component library or as HTML, and that's the source code. And then developers use their editors to go inspect it and stuff. That is then sent, and we're going to be ignoring, this is a simplified version, we're going to be ignoring server-side rendering and fetch calls and everything. That is sent to the browser, and the browser renders that source code as a DOM or an accessibility tree. These are tools that the browser uses to contain all of the information that the source code has and have the states of what the user is interacting with all stored right there. So DOM's document object model. And the accessibility tree is a tool that you can use in DevTools to look through basically what every accessible element is, what the name is, and role and value. So these are tools that are created from the source code by the browsers. So Chrome and Firefox and Safari, they're going to take that source code and they're going to generate it into a renderable content for the user. Then the computer that the user is running makes a difference. So if they're running Mac, it's going to be a different experience slightly than if they're running Windows. And obviously, that's the case if they're using a completely different screen reader, like VoiceOver versus NVDA. But what I'm trying to point out here is that the actual operating system plays a role in this. It's got something called the operating system accessibility layer that takes the browser's DOM and has kind of like a point for screen readers and other accessible technologies to interact with and make calls for I need this thing, I need this thing. And that's implemented by the operating system. So that's another point where the information is being passed through to then get to the assistive tech. So this would be NVDA, JAWS, or something. So NVDA communicates to the operating system, and that communicates to the browser, which is generated from the source code. And then all of that is sent up to the user for the user experience. So this information of the original source code gets sent along this chain all the way up through these different black boxes up to the user for their experience. And this is important to understand, and it's a bit technical, but it's important to understand because different testing tools fall at different points on this like on this line. So source code is the beginning and going all the way up to the user. Source code is where linters, which is I'll talk about and define in my next slide. Linters are tools that will look through the source code and try to find issues. Linters live in the source code. Scanners, AXCOR, Wave, flow analysis, they live in the browser. They live in the DOM, the accessibility tree. They're not touching the assistive tech or the user like operating system accessibility layer. And then manual testing, which is the gold standard for accessibility testing, is all the way up at where the user actually experiences it. So there's a bunch of these, and I have also listed up there accessibility end-to-end tests, which is a newer technology that I'll get to later in the talk. But basically, what I'm trying to point out here is that linters and scanners are down here at the bottom of this kind of chain. And there's a lot of spots for things to go wrong past the browser. There's a lot of areas for some kind of implementation to cause some kind of issue. And so necessarily, we can't claim that linters will find all accessibility bugs. We can't claim that scanners will find all accessibility bugs unless they get way vastly different in their implementations and that they're now running NVDA or something. You know, they're now doing extra steps to make sure, and they can find a lot of issues, but they're not going to be able to definitively say that this issue does not exist for the user because they're not living in the user's realm. They're not living over there. So yeah, zoom in. Have any questions before I move on? All right. So let's talk about linters, as I was saying. Linters scan through source code to find common accessibility mistakes, issues. And this is not tied specifically to accessibility like Lewis was saying. Linters have been around for a while. They originally existed to try to find syntax issues so that you don't, you know, it's easy to know if you have a missing curly brace or something. And these are great. Linters are wonderful. They give you consistent results. They're a bit limited because they only have the source code, like I was mentioning in the last slide. And they're context blind, so they don't really understand, you know, if you just have code that's trying to implement this element for a specific reason, they don't know any of that. It's just, is this attribute missing that should be there, you know? So it's great for saying, you created an image, it's missing the alt attribute. It's gonna, you know, give you a warning if you have this ESLint plugin JSX Ally plugin installed. And they're unable to test interactions. They can't do any kind of tests that involve clicking an element, activating an element with enter or space, or using voice command to activate an element. They're just the source code, and they're reading through the source code, and they're giving you results about that source code. Yes, Lewis.
I'm pretty sure this is correct. They can only follow whatever rules that are entered into the linter.
Mm-hmm.
So you were talking about AXCOR.
Mm-hmm.
If AXCOR complete is there,
Mm-hmm.
then it can test for everything that AXCOR looks for.
Mm-hmm.
But if it's a subset, it can only see that, right?
Totally.
So that's another piece of the positive and negative of linter is if you didn't get the right rule set, you
Totally.
didn't get the right answer.
Yeah, 100%. And that's a big thing with like these like ESLint plugin JSX accessibility, like that. If you don't have the like an accessibility forward linter installed, you're not going to get that alt attribute warning, you know? So a bunch of developers who know nothing about accessibility probably aren't going to install this, and they're not going to then get the, you know, so a benefit would be if some of these like default linters like VS Code or like all the packages they install by default, if they included the accessibility ones, you know, like these would be beneficial for people to just have because it's free. You just get a free information about you are missing XYZ in your code that you need to be accessible, probably. So yeah, if you don't have the certain things, if you have things turned off, you can turn off linters entirely if you want to code wild, you know, but I wouldn't recommend it. Test Party is a company that also, they're using artificial intelligence to augment their linters. They seem to be doing more stuff than linting now after their most recent talk, but their entire focus is, okay, look at this entire source code, and now send it into an AI chatbot and tell me if there are accessibility issues. So that's more complex linting, but at the same level, it's linting because it's going through the source code. Static code analysis. This is a big one. This is the one that everyone really knows about as scanners, really. And these are great. They test on the actual rendered web page, the DOM or accessibility tree that I pointed out from my graphic before. they're still context blind. They still don't know why you're creating this element or what role it serves in your user flow. And they're still unable to test interactions for the most part. They can't activate a button and see if focus falls to the right spot. But they give much broader coverage than linters. And they're able to, like I was talking about before, they're very quick, fast. You can scale them you can scale them to your whole website. And these ones include Axe Core, Accessibility Insights, Lighthouse. And just for a little example, I'll show, I'm sure everyone's seen this, but I'll show a little example of, so I like to use Accessibility Insights because for web, some fun fact, I don't know if everyone knows this, but a lot of scanners just use Axe under the hood. So Accessibility Insights for web is just Axe, but I like its UI a little bit better, so I like to use it. So I'll click FastPass and it'll scan, and it found no issues on the our Assistive Labs website. So maybe that wasn't the best example. Issue. So this is just an example of a scanner. You just get some issues here and it'll tell you, okay, this HTML snippet does not have a title element. All right, that tells you what kind of success criteria. You can look through it and go through all these things. And yeah, they're wonderful. They're a great tool for getting just a wide amount of information from your website. And they don't dive into everything, like I was saying, but they give you, they give you resources. They give you data that you didn't have before. All right. Did I lose my slides? All right, let's go back here. Whoops, skip ahead. All right. So that is scanners. Now let's go to flow analysis, or as I like to call scanners plus plus. So this is scanning across a bunch of different states of your website to complete a user flow. So let's say what we just did back there, we went to the home page and we scanned it. Flow analysis would be automatically like setting up a flow that goes to the home page, scans it, clicks the sign up link, scans it, enters in a user input, scans it, and does a bunch more scans than just one single scan pretty much, and gives you more information. So you get like a dropdown, you expand it, and then you scan, you get information about that expanded dropdown state. So it gives you more. It's the same pretty much as a scanner. It's just a little bit extra information. So it's still context blind. It still has the same issues that scanners have, where it doesn't fully understand why you have a specific implementation and what that means for your website or your user flow. But it can now find some interaction bugs. It can find if you open up a dropdown and something is broken because of that dropdown being opened, it might find that. It's not guaranteed to find everything, but it can find more than just a single scanner. Some examples of these are Axe Core Watcher, Evinced Flow Analyzer, Playwright. If you were to take Playwright, which is like a regular testing tool, and add Axe Core as an extension, that would work the same way, and do some scans. So yeah, these are great and important to distinguish between just regular scanners. Next is accessibility end-to-end testing. This is a newer thing, and I promise not to do too much of a sales pitch because this is something that my company does. But it's about writing, it's something that I think a lot of people do already and aren't aware of it, is writing specific end-to-end tests to maximize accessibility coverage. So this falls into that automated category before. All of the ones before this were automatic. This is automated, where you take a specific thing. I guess flow analysis could be kind of automated. You take a specific thing and you're trying to guarantee that it has this coverage, and you run that as many times as you want at any kind of interval that you would like. So this understands a bit more context than scanners because a human originally wrote the test and had some information in mind about what they thought was important to measure for accessibility. But it's still less than a human test, obviously. It can test interactions now because you're going through a test flow. So just to, I guess I should probably explain end-to-end testing if anyone doesn't know that, but that is testing an entire user experience from one point to the beginning. So say, I want to make sure that a user can sign up for a free trial and upgrade their free trial using Stripe. You will create a test that goes to the home page, goes to the free trial page, goes to the sign up button, activates it, fills out their information, goes to the settings page, goes to the upgrade page, does all of that, and you will test from the beginning to the end. You'll verify that. You'll write a test that does that, and then you'll run that test, and the test will be in a regular end-to-end test, very quick. It'll run in like a minute, maybe even less, if it's a short, flow. And then you can run that every time you make a change to your code base. You can run it daily, you can run it hourly. And yeah, end-to-end tests are great. They're a super useful tool for guaranteeing that your user flows still work as expected. Accessibility end-to-end tests is taking that to the next level. It's taking an end-to-end test and then adding at each point a bunch of accessibility checks. So you're like, okay, go to the sign up button, go to the sign, make sure that the accessible name is good. Make sure that the label is in the accessible name. Make sure that the focus ring, when you focus it, is there and it has the exact contrast, the minimum contrast you want. So you're doing extra steps to the end-to-end test to make sure that accessibility exists how you would like it to be. These can test actual user experiences. So thinking back to that graphic I showed, this is testing on the user layer because you've now gone through everything and you've rendered up the entire web page. You've booted an accessibility technology, and you are now interacting the same way a user would. And it's using what the screen reader announces. It's looking at what the page looks like using machine vision and doing some pixel stuff. So examples of this are obviously Assistive Labs has an end-to-end service. GuidePup is a wonderful open source tool I think everyone should check out, where you can, they added NVDA too, but you originally started as a voiceover automation tool, so you can automate and write tests with voiceover speech. Playwright, Cypress, and Selenium are all end-to-end tests, and they're starting to add accessibility features to them. And you can take a Playwright test and beef it up with accessibility information, a bunch of stuff that you want it to have. So if you work at a company and they already have an end-to-end suite, you can try to hop onto that. You can latch onto that and say, okay, I'm going to take that suite and I'm going to add XYZ tests about accessibility. And now you've just gained a bunch of information. So let's do I'll do a little show what the end-to-end example looks like. So this is a sign-up flow on our website. It has a lot of checks baked into it that are making sure accessibility is how it should be. And it requires being written by a human, so it's automated and not automatic. So this is an example of a test report, and I'll just show you the video so you can see. And for everyone who can't see the video, it will have a screen reader talking, so you'll hear what the screen reader is going through. And so we can show the video afterwards. But I'll just walk through the video as it's doing it and explain everything. And yeah, we won't have the full screen reader announcements, but you can picture what's going on. So we're loading the virtual machine. It's booting Windows. It's launching NVDA. It's turning on vocalization so we can hear it. And then it's going to launch our Assistive Labs website to start the test. Now we need to get to this start free trial button. So we're going to start tabbing there. You can see the speech at the bottom is going to say skip to content link. We're going to tab to the navigation landmark, the Assistive Labs link. We're going to tab to the use cases button. It's an expandable, so it says collapsed. We're going to tab to assistive technology. And at each of these spots, it's doing a bunch of automatic checks about accessibility. So this is combining automatic and automated. And I'll show what they are in a bit. And then we tab all the way to the start free trial button. It announces start free trial link. It's actually a link, not a button. And then we get to this enter email address field. So let me show you some of the things that are in the example here. So for like going to the free trial page, we're tabbing through all of these elements, and we're visiting the element, and we're expecting them to have the right role, accessible name. We're doing some focus ring checks. So if we look at every element that's, oh, let me move this. If we look at every element that's visited, we can see that we're capturing what it looks like focused and what it looks like unfocused. And on here, I'm displaying an image of every element that's been visited and how it looks with a focus ring and how it looks unfocused. And then there's a diff that's showing the difference in pixels from the two states. And then a contrast field that's showing what that calculated contrast would come out to. So this is just some of the things that like you can bake into an end-to-end test. So you have the test set up to do this flow, and you can add things that you want about accessibility to make sure that the focus ring, if the focus ring for the start free trial or the sign-in were to disappear, this test would fail, and you would know about that immediately. So that's really the benefit of something like this. So this is a graphic I have up here that's a bit of a Venn diagram to show the kind of coverage that these different tools can get. So to describe it, I have a large circle with manual human testing, which is the gold standard for accessibility testing. This is auditors, UX research. That is all coverage that can be gathered pretty much, right? Code linters fall into a small little circle, and this isn't exactly to scale. This is just to show kind of how these tools overlap. Code linters fall into a small circle. Static code analysis falls into a separate circle that has some overlap with code linters. And then analysis and flows is a larger circle that encompasses all of static analysis and more of linters. And then accessibility end-to-end testing is this whole area that's completely uncovered by these traditional tools. And there's still a bunch of areas that aren't covered by any of these automated tools that you need manual human intervention to guarantee that the accessibility is there. So let's go through some issues, and we will see what tool can find it and what tool wouldn't be able to find it. And before we go into this, anyone have any questions about some of the stuff I was just talking about? Take a sip of my coffee. All right, so first issue, missing alt text. This is a classic one that everyone uses. It's very easy. It's related to the non-text content success criterion. So let's say we have this image on our homepage that has a graph showing the different usages of screen readers. And so it shows JAWS with 40%, NVDA with 38%, VoiceOver with 10%, and then other screen readers with 12%. So before the image was an image with an alt that said pie chart showing JAWS at 40%, NVDA 30%, et cetera, and had a source for the image. And then after someone made a change, they deleted that somehow it got removed. Now there's no alt text, and it's just an image with a source. So a linter would find this. A linter would say you're missing alt text when you're editing the code, and you need to have that. Static code analysis would find this. It would say this image is missing an alt. It needs that. Flow analyzers, which is like static code analysis, would obviously find that too. End-to-end testing would find this. Everything would find this in the automatic and automated categories of testing. So let's move on. Let's get a little more complicated. Bad alt text. This is a great example for showing the differences of like what ACTS can and can't cover. So you have the original alternative text, which is a pie chart showing JAWS at 40%, NVDA 30%, et cetera. And that gets changed to cat riding a unicycle. I don't know how that would happen in production, but let's say this is an extreme example to showcase how it could go wrong. Say someone changes the image themselves, and then they're trying to update the alt text, and they do it very poorly, and it gets you a bad alt text that's not very accessible. This would be able to not be able to be found by a linter because there's alt text there. It would not be able to be found by static code analysis because there's an alt text there. It doesn't know if it's good. It could be found maybe by an AI tool that's using static code analysis or linting. It wouldn't be able to be found by a flow analyzer for the same reasons. It could be found by end-to-end testing, but it still requires human review because it's you can automate that the test asserts the alt is what it was before, and then if it changes, you'll get a notification. But the test won't be able to know still automatically if that text is bad. So you still need a human in the loop, but you'll get a little bit more. You'll get a ping. You'll get a notification that maybe there's something wrong, a warning. So let's go to missing focus ring. So this is important for focus visible. You have a element that when you tab to it, there's a use cases dropdown. If you tab to it, it's got a focus ring wrapping around the entire element. And someone does the dreaded like display outline none or something to this section. And so this element gets no focus ring or something. So now when you tab to this element, you can't see that your tab is on, your focus is on this element. So this would not be able to be found by linter. It wouldn't be able to be found by static code analysis. It wouldn't be able to be found by flow analyzer. It could be found by end-to-end testing if you have tests set up that are checking, make sure that this focus ring exists. Make sure you do a focus ring check. It can be found by manual auditing, obviously. But yeah, so this is one of these examples. Focus drops to body. This is one that I think is really important because people don't talk about it as much, but it's super common. It's one that I see all the time in the industry where someone has set up focus management poorly. And so you activate something, and then your focus gets thrown all the way to the body, and you're no longer in the thing you were at that you needed to be in before. And now you have to tab 40 times to get back to where you were, and you're all confused. And it can present a number of issues. So in this example I have, you're navigating to a dropdown using tab, and you activate it with space. Before the change was made, focus falls to the first item in the newly expanded list, and the screen reader announces that list item. So that's great. That's what you want. someone makes a change that removes a ref or does some kind of management that causes focus when you open this dropdown to fall to the body. So now the screen reader just announces the document title. And so someone who's using a screen reader activated this dropdown and they got confused. Why am I not in the dropdown or activating or moving with the dropdown like I was expecting? So this, once again, is only able to be found by an automated test that is specifically looking for it. A static code analysis wouldn't be able to find it. Linting wouldn't be able to find it. Flow analysis wouldn't be able to find it. Human auditing definitely can find it. But what's interesting about automated testing is that in some areas, you can get even a little bit more coverage like than a human would be able to be fine. Something that we've seen is that focus sometimes, I mean, you'll see it in the NVDA speech, but focus will get dropped to the body and then very quickly reapplied to where it was supposed to be. That was someone's patch fix for fixing their bug. And so the screen reader will announce that the focus was on the document title. It'll announce the document title, and then it'll announce the element it was supposed to be. And some manual auditors will see that and say, oh, it's announcing the right thing. It's announcing the element that it's supposed to be on. But they missed that it actually, for a second, was on the body. And that's confusing. That's still a failure. That's a focus management failure, even if it was just for a brief millisecond, long enough to announce to NVDA. So automated testing can find that a little easier. And you'll notice that the thing that I'm trying to point out here with these last few examples that can't be found by a lot of test automated tools is that interactions are the key. So most automation can't test interactions, but interactions are how users interact with the web. It's how everyone is navigating the web. It's how they're being involved in what's going on the page and communicating. And so they're extremely important. A user really only experiences the page through interactions. Interactive elements also have so many permutations of state. So a Dropbox can be, or dropdown, not Dropbox, whoops. Dropdown can be expanded or collapsed. It can be selected or not selected. It can have this value. It can have multiple values, a single select, multi-select. There's a bunch of different ways that an element can change based on the interactions. And so if you're just scanning the page, you're missing all of that. You're missing this whole swath of ways in which the user is going to experience the page that the scanner doesn't. You're missing autocomplete suggestions, second order effects. Someone makes some change that's causing, when you press this button, it breaks the header over there. It does some weird thing. That happens. That happens in the real world. And you only get that if you're doing a manual audit or if you're doing a specific test that's checking just for that one thing using end-to-end testing or something like that. So does that mean that these scanners and linters are useless? Absolutely not. These are wonderful tools. They provide an ability for people to get more information about the accessibility on their page, on their code. They're wonderful for giving kind of education about accessibility. Like we were talking about before with linters, it would be great if accessibility linting rules were involved in like testing tools automatically so that people could just get this information and be like, oh, what is an alt text? Why is it giving me this red squiggly line that I'm missing in alt text? And they'd look it up and they'd understand and they'd get, so that's great. Linters are great. Code analysis is great, and they are great tools. But you need to understand the limitations. You need to have your bullshit detector, like I was telling you, you have to have it tuned in so that you can understand what areas you still need to cover with manual testing, with UX research, with specific end-to-end tests. You can't just say that I'm doing a scan of this homepage, and so the homepage is now covered. And obviously everyone knows that, but I think it's important, especially now with some of these claims that are coming out from large companies, to know what still just is not able to be covered automatically. And an important thing is that these tools are always constantly evolving. So automating screen readers with end-to-end tests is relatively new technology. It's something that's very exciting to us at Assistive Labs, and it's something that I think is going to be really useful for validating tests and how finding new issues. But it's something that's just happened in the last couple of years, you know? And so there's going to be new things that'll come out soon in the future that could make even more changes. So it's always evolving. It's important to be on top of what exists and what it can and can't do. So that's the point of this talk, really. So let's go back to this automatic versus automated distinction I gave before. And we'll talk about kind of the coverage they can give. So automatic tests, they have this high breadth. They can get a wide swath of issues by finding a lot of different small issues through all of the pages on your website. But the depth is pretty low. It can't go into every single success criterion and find every possible permutation and way that it could be present. Automated issues have a high breadth as well. They can be set to a large page on your website, a bunch of flows, a bunch of different things. It's a little bit harder. It's a little bit more expensive to implement them, but it's still a high breadth. But their depth is that they're variable. They can be low, they can be medium, they can be high, depending on, how you set them up to be. So I have two graphics here showing. One is showing the Assistive Labs homepage with just a bunch of different banners and headers kind of highlighted under the automatic section. And the automated section has the same Assistive Labs homepage, but now it has all of the elements that were included in that flow that I talked about for getting to the sign up button. All of those are highlighted. So those are now included specifically as part of the depth. So not every element, not these elements down here, these weren't part of the test, so they're not included. But all the elements that we visited, we're getting a lot more coverage than we were before. And that's an important thing about automated testing versus automatic testing. Now, the question that everyone I feel like is wondering at this conference is, what about AI? There have been a lot of talks talking about artificial intelligence and the ways that it is gonna make a big change in the accessibility community. And I think it's important to have some skepticism. So I don't think AI is going to solve accessibility. Accessibility is a difficult problem that has, like I showed you on the tech stack, a million spots for errors to be introduced and things to go wrong. The training data for machine learning, large language models, is practically non-existent. We know from Michael's talk yesterday in Test Party that 95% in the WebAIM study, 95% of websites currently that exist have some type of inaccessible code. There's some way in which their homepage is inaccessible. So that means that all of this data that's being fed into machine learning algorithms for how to write code for a website, a lot of it's inaccessible. A lot of it is just bad code that does not represent what a good accessible website should look like. There are also just too many unique cases. Every company has their own kind of custom way of implementing some dropdown that has some way of breaking accessibility. And so that's always going to be relevant. Hopefully that gets like I don't know, we don't have a new framework every few years that causes issues, but there's always going to be unique cases that AI has never seen before. It wasn't a part of the training data. This company developed it themselves. And so how is AI going to be able to solve for that? It's not. It's prediction based. And then another important thing is that hallucinations with AI generates something that's completely based on nothing. It's just coming out of nowhere, are not acceptable when it comes to compliance testing. You can't have a tool that's generating random results and have that be a part of your production pipeline. That's just unreasonable and going to cost you more than it'll help you. And false negatives and positives need to be near zero if they're going to compete with manual testing or scanners in the real world. If you have an AI tool that sometimes finds issues and sometimes doesn't on the same input, that's not good. Like I was talking about the non-deterministic, but also it can't be finding issues that aren't there. It can't be missing issues that are there. So let's go down the rabbit hole a little bit. This is going to get a little AI centered, but I want to point out why I think AI is not going to solve accessibility. So a brief crash course on how large language models work, super simplified. I recommend watching 3 Blue 1 Brown's Large Language Models Explained Briefly video. He does a much better job than I will at explaining what's going on. And it's a wonderful visualization too. But the way that LLMs work is they're probability-based generation. So they generate text by picking the most likely next token based on all of their learned probabilities. So you take a bunch of training data and it's turned into tokens, which are like numbers. And then you take all of the context of how these numbers are layered with each other and what they do next to each other, and you feed it tons and tons and tons of data into this training. You get a bunch of matrices, you get a bunch of things, and you're used to evaluate, okay, I've seen this word most likely after these previous words, so probably the next word is this, So that's why a lot of people have talked about it as a glorified autocomplete. You're taking autocomplete and you're giving it trillions and trillions of tokens of data, and you're making it better. You're making it sound more like a human, but at the end of the day, it's still taking data and it's predicting what the most likely next token is based on that training data. So if the training data doesn't include anything about what you're actually asking for, it's not going to be able to predict accurately what the answer is. If you ask it something, if you create your own language, and then you ask the AI, giving it some information like what this thing would be, what the next word would be in your own created language, it's going to struggle. It's not going to be able to do that well because it doesn't have the training data for that language. So I would recommend checking out this video, and it does a great job explaining it. But I wanted to talk about probability-based generation because an important thing is training versus fine-tuning is a distinction that needs to be explained. So training is the foundation for LLMs. It's building the model from scratch based on a large amount of data. So these are companies like Google, OpenAI. They have tons and tons of data already collected. They're buying data. They're generating more data, and they're taking it and they're creating a model. And every new month, OpenAI releases a new model with new swaths of data and money spent and energy spent training their model, and it finds patterns. It's just getting more and more information about the real world and what are patterns that exist in words, text, accessibility. Words, text, code generation. Fine tuning, though, is where you're taking that model that already exists and you're just adjusting it a little bit. That's like if you've seen all those people who are using ChatGPT and they're like, pretend you are an expert accessibility you're giving it this extra information, but the data it's trained on is still widely inaccessible. You're adding this extra sprinkle on top of you are now focusing just on these parts of your data that you trained on. But if the data is not there that much, it's still not that useful. So it only tweaks the model weights, fine tuning. It doesn't rebuild the core knowledge. And it's maybe only thousands of examples. So let's say you have billions of examples of inaccessible website code that was trained to create the OpenAI's GPT-4 model. And then you fine tune it by giving it a bunch of WCAG success criterion definitions. You give it some examples of accessible code. You add all of that into your prompt, and then you ask it to find accessibility issues on your page. Compared to the data that it was trained on, you have added less than 0.001% of the data that it has available to give you an answer. So it's going to look at all of the things, and it says, oh, I found 1,000,000 trillion times that there's an image without alt text, and you told me once that I should have alt text. I'm going to listen to the 1,000,000 trillion times that I didn't get alt text in my training, and I'm going to give you an image. That's an extreme example, but it's important to highlight because unless someone is generating an accessibility large language model trained only on accessible code, I will never trust that it is able to find a large swath of issues, because it'll just be hallucinating. It'll be missing things that it shouldn't be missing. It'll be trained on inaccessible code, and it'll be using that as its backbone. And there's also bias in LLM training data, like I was talking about. They're trained by large companies on huge sets of data. Gemini Ultra used 30 trillion tokens by most estimates, which is just an insane amount of data. It's just unimaginable. And we know that 95% of sites are in some way inaccessible. So most of that data of that code, is inaccessible code. So fine tuning with accessibility specific examples is a drop in the bucket, like I was talking about before. And another important thing that I feel like not enough people talk about is that AI is expensive. Sure, a lot of things that we do in tech use energy and are expensive, but AI is really expensive. AI is driving up costs of data centers and compute all over the world. So the computational power for sustaining AI's growth is doubling roughly every 100 days. And I'd recommend reading that article that I linked there. And that's an insane thing to think about. The power that we are using that's already astronomical from these models. And there are people who are talking about that some of these compute centers are now, Google's compute centers are using more energy than small countries. This is an insane amount of data that's being used, that's going up because of AI specifically. And it's doubling every 100 days. And so it's not to say that you shouldn't use AI because it's bad for the environment. Maybe it's to say that, but when a trend like something happens, that's like, oh, here's an AI generated image of what I would look like as a Studio Ghibli character. That's really cool. But then if millions of people are doing that, image generation is expensive. It costs a lot of energy. So millions of people generating images costs a lot of energy. And it's now that single trend drove up the energy cost and carbon emissions by XYZ, just because it was like, oh, a fun little thing that the AI can do. It's not useful. It's not generating any value in the world. And so I don't think it should be something that companies are prioritizing and showing, oh, anyone can do this and just, it's so easy and you should be doing it as much as you can. Google search is a great example of why I think this issue is really prevalent. So Google search now has the AI overviews every time you search it. I don't know if you guys have all seen that. And it's just like, okay, cool. And you scroll past it. Sometimes it's useful, which is great. But the issue is that it costs, now Google search costs 10 times the energy it used to because of the AI overviews. So overnight, when Google added AI overviews, they 10x their energy consumption for Google search, which already was, not crazy, but it was high. And so this is like companies that are taking what they already have, which is expensive energy. We're in an economic crisis. And then now they're adding AI to it at scale because they have the money and the resources to do it. And it's costing so much more energy. It's crazy. Image captioning, which is like generating alternative text from an image using AI, could cost anywhere from 0.06 to 0.2 kilowatt hours per 1,000 requests. And the thing about these companies is they don't really release exactly how much energy consumption is used for their tools. So this is an estimate. But if we take one of the examples like from that Michael from Test Party was talking about, where they're generating 10 million images, alt text, every year for this website that has like user added images. If you take 10 million requests and you're using that kilowatt hours energy, you're getting like an insane amount of energy that's just like, does that need to be used? Does that need to be, I'm not saying that that energy takes precedence over alternative text. I'm saying that it's a conversation that should be part of the conversation, is that energy and AI is expensive. And maybe there are alternative solutions that we should be prioritizing that don't involve costing as much energy as AI does. Do you really need an AI solution for this, this thing that could be solved by a human? This thing that can be solved with the same amount of money, with better training for your team, And it does have some use cases, AI. I will say it's great at, like I was saying, generating and validating alt text at a large scale if you ignore the energy issue. It's cool with agentic flow completion and ignoring testing. If this were to work, like if you could say, I want to go check out 5 batteries from an online website and get them delivered to me, and you just send that to your AI chat and it does it for you, that'd be a huge benefit for actual disabled users. Then you don't even have to use a screen reader theoretically. Like I don't think that this will happen, but if it were to get to that point, that's an interesting area to explore. And it helps with accessible code writing. Test Party is generating some of that, and it allows you to get some insights. Machine vision is kind of cool, but it still has a long way to go. It's not going to solve accessibility. It's not going to be the golden, thing that's going to make accessibility easy. Accessibility always is going to be hard, and it's always going to be human. It's always going to involve human research, user interaction, user test studies. AI is a tool that is being, this talk is about hype. It's being hyped up. It's new and it's exciting, and it's very interesting to look at how it works. But it's just, I think right now, a lot of hype. And so everyone should try to be a little skeptical of what it can and can't do. All right. So here's some takeaways just from the talk as we're wrapping it up. Automation is more than just page scanners. There are different types of automation. They fall into different buckets. Everyone should take coverage claims from companies with a grain of salt, understanding what is actually available to these tools and the information that they have and what they can and can't do. Manual testing is still the gold standard for compliance. Newer types of automation are exciting, and companies that are working on new types of accessibility automation, that's a fun field to be in, and there's cool stuff that could be happening in the next few years. But you should be skeptical. You should be skeptical about claims. You should be skeptical about what I'm saying for my company. You should be skeptical about AI coverage for sure. You should. The key takeaway from this talk is that you should always be second guessing if someone says they can cover something with automation. You should be like, okay, but how? What is the way that you're able to do that? And how is it that much better than a user test? How is it better than manual? Is it just that it's faster and cheaper? Can it actually do the exact same things and faster and cheaper? That's kind of the standard you have to be holding it to. So here are my slides again, and I'll open the floor for any questions. Yes.
I've heard about that Axe product. I think they call it Userflow. never used it, but it seems to fit into one of your Venn diagrams.
Totally.
Yeah.
Yeah.
But it seems tough because it's automatically capturing your steps, right? Rather than you custom
Mhm.
writing your steps to click this button, click that button.
Mhm.
I think it must be brittle. Do you have any experience or thoughts?
I haven't. I've been meaning to test it out. It's like, yeah, it's, it's behind the paywall, so I haven't experienced it myself. But I think that, yeah, there are ways in which you can just look at the page and like, what's it called? Like back in the early days of the internet, the way that they found websites was like crawlers, right? They crawled through the page and found all the links, and they added that to their index of links. You can crawl through a page and find every interactable element and click it and have that be a part of your testing scanning. So if you take a scanner and it's set up to go to your homepage and then click every button and scan it, that's a way that you can get more scanning coverage. It's going to break things. It's going to have not the best, it's not going to be as fine-tuned as someone saying, I want a user to go from here to here and do X, Y, Z. And maybe Axe-Core's user flows is using AI to be like, all right, what are the buttons I would click to get from X, Y, to Z? Maybe it is. I'm not entirely sure how they're implementing it.
I heard an effort to find all the things and then just branch out infinitely, but it didn't really go anywhere. Like, have you actually heard of anyone doing that, like without AI? Just
I've heard of people doing there's some people at like the accessibility team at Amazon were doing something similar to that, where they were tabbing to every element on the page and trying to branch out from that and activating them to try to get like it was like focus is always going down and to the right, so that you get like focus order in some way. But no, I haven't heard of someone actually clicking every element and going. The issue with that is you can't point it at production. If you click something that like deletes a user's account by accident, like you need to have it in a sandbox testing environment. So I've never heard of that, but I bet it exists. I bet people are doing it, and I bet it works in some specific cases.
I think that just goes to your overall point, the limitation of automated.
100%, 100%. And it's like it's a thing that you think about, oh, that's cool, that could totally work, but is it working? Is it in production now? Are people using it? Like, you need to think about that if you're evaluating if a tool is something you want to use. Any other questions? Yes.
Going back to your video test,
Mhm.
the slide earlier,
Mhm.
what kicks that
Oh.
off? What are you telling it to do? Is it looking for like an ID on the page for that login?
Like this
okay.
one?
Yeah. So how do you start that?
That's
So
that's a great question. So I can show actually some of how we format the code. Well, let me pull it over here so you guys don't see all my code. Okay. So the way that we're kind of, let me make my text bigger. The way that we're getting that is we're taking this start free trial link, and we're encoding it into an accessible target, which has a name, a role, a value, a visible label, and then we're focusing it, which defaults to using tab, and we're asserting what the speech is going to be, and then we're activating it using invoke. So this is like the kind of way that we're writing down. You take, this is the element as its state, as what it is, and then behind the hood is using get by role selectors, using the accessible name to narrow it down to all the links with that exact name. And then you're validating that the visible label that you see is the same as the accessible name. So you get some extra checks there if that were to change. And then you get the speech encoded there. So it's all like kind of hard coded in. So the test takes a while to get up and running and written originally, but now you have all of this there.
Great.
Nice. Yes.
So I know you're saying the end-to-end testing is like relatively new, but I know how fast technology moves now. So I just want to know, from the time it really kind of, began till today, big evolution. Do you see it? Changes coming?
Totally. Yeah, I think it's changed a lot. And I see there's someone raising their hand on the Zoom call. I'll get to in a second too. I think it's changed a lot in the last like year alone, maybe 2 years. Like, at least at our company, it started 2 years ago, and it was like, it would take like 10 minutes to run through a flow. It was very slow. It didn't have all of the coverage that it has today. And now it can be parallelized and you can run like 100 tests in like 2 minutes with a bunch of VMs in the cloud. And the flake has gotten reduced a lot. So GuidePup has done really cool stuff where they started with just voiceover and it was very basic and it was just press this button, assert that the speech comes back. And now they've added a bunch of stuff. They've added NVDA, they have added the ability to use cloud VMs. And so I think that it's something that a lot of companies are probably going to start adding is end-to-end test cloud VM architecture. And I think that in the next few years, it'll get just better and better at reliability, like making sure that the flake is near zero and making sure that when it does find issues, the reports that it gives are better. Because right now, like it's something that, it finds an issue because focus fell to the body. You have to figure out how you're gonna, how you say that happened. You have to say, okay, focus probably should have been here. It was at this body, So I think that's something that's going to get a lot better is the ways that it's the user interface is easier so that people can understand the results. Yes, Claire.
Hi there. So I am in Portland,
Mhm.
Oregon. Can you hear me?
All right, I have you on the little laptop and I'll repeat it to everyone in the call.
Oh, hi. I am in Portland, Oregon. So I know your colleague Andrew.
Nice.
And thank you for sharing. You touched a lot upon about like several things that I thought were really relevant and really amazing given your life experience and your background. So thank you as far as linguistics and whatnot. But I wanted to ask about and AI. I wanted to ask about the testing tools and what you, as far as like the next phase as with AI and integration and language modeling, what you see, what do you see as the next step for it being integrated? Obviously not taking away from
Mhm.
the human interaction and testing and manual pieces, because it will, I don't know if it'll ever take away, like human interaction is necessary. And what you were saying is an excellent point, but do you see what that next phase might look like or what you can given technology now?
Yeah, totally. So Claire just asked for everyone in the room because I couldn't hear it. Claire just asked what I thought about AI and where it's going to like find a space in accessibility and what use cases it'll have, not replacing human testing. I think that's a great question. I think that AI has some specific use cases that are good for, I have a company issue. I have this specific thing that I need solved, and I want this piece in the pipeline bridged. I think AI can do some small things like that. That's like, oh, this specific thing, I need this data sorted in a way before it's sent somewhere else. I need this data cleaned and scrubbed before it's sent somewhere else. You can do that deterministically, and that would probably be better. There are ways in which AI can maybe do that, and it would work. I think a cool thing that could be explored that I've tried messing around with, but I haven't done myself, is doing something like you were talking about, where you're going to a page and exploring everything and activating all the stuff. Doing that with AI, taking an AI agent with NVDA, pointing out at your website and say, just mess around, just touch every part of the website you can and see if you find any issues. And that's great because you're not going to be guaranteeing any compliance. If it finds something, you can verify it as a human and say, oh, that's interesting. I didn't see that little small part in the footer. And so I think it'd be a cool extra additive tool. Is that worth the energy that it takes? Who knows? But I think that there could be some cool use cases there with agents that allow for exploratory testing, but not definitive compliance testing.
I have
Hope that answered your question.
one last question.
Oh yeah.
Sorry. Thank you. So you spoke to the bullshit or BS meter, or what I call snake oil and accessibility, the snake oil sellers. How do you feel that with automated testing and these tools, how is someone who's new to the field? I'm not new, but I can detect that, but how is someone supposed to be able to detect that other than being involved with conferences like Access U and whatnot, and being in the field? Like, how does someone starting out know what is the snake oil or the BS versus the reliable and validated tools?
It's a great question. So Claire asked, how does someone build up their like bullshit detector to figure out what is snake oil and what isn't, and what's realistic claim coverage and what isn't, if you're not, maybe going to all of these accessibility conferences and you aren't fully invested in the space? I would say there are a few ways that you can build that up. The first of which is just, if you can, like try to read some of what people's reactions are in articles, like Craig Abbott releasing an article about X, Adrian releases wonderful articles in reactions to things, and they call out things. They say what actually is from like an expert's perspective, what they think something can and can't do. And that's a great way, is leaning on the resources that other people are, the advice that other people are giving. Another thing is just always looking at kind of like the use case, like the studies, like people, if there are clients that this company has that are doing it, seeing if they have any released information about that, if they're actually saying what they can and can't, if there's data available, trying to look at that. But yeah, I'd say that the main thing is trying to rely on other people who have this like good, expert, strong, hard opinions, and trying to just look around for what the alternatives are. If you're looking at just the landing page of someone's product tool and you're using that as your only reference, it's going to be exaggerated. It's going to have flashy videos to try to get you to think that it's really cool. And that's great. That's, that's a business strategy. But you should be looking at any kind of third-party opinion. You should be looking at anyone who has interacted with it, if they have a review, if they have any ideas about it. And if none of that exists, you should try to be getting demos from the company and asking them, can you back up these claims that you're making? I need to know exactly what the thing is that's happening here to get this validation and coverage. Because at the end of the day, it's you're responsible for your website's accessibility. You're not, if you use an automated tool, you're not outsourcing all of your responsibility. You're not putting it off to some other team because you paid them for it. You're still the one who had to evaluate and decide if it was, actually getting the coverage that it claims it does. Awesome. Any other questions? Yes.
Your question. So I saved the best for last. So automatic checkers that have a crawler also, like Axe has the browser extension, and then they have their crawler offering. I think it's called Axe Monitor. I work for SiteImprove. We have the same thing, and there's many more. I've seen a big aggravating factor in the crawler version of our thing, internally. Which is when is the page finished loading? Nobody knows.
Yeah.
We have like heuristics and await and Puppeteer, Network Idle 0, and sorry everyone for the obscurity. But the question is, nobody has a robust way of telling when the page is finished loading. And this leads to a lot of both false positive and false negatives in the crawler-based automatic checker that usually didn't exist in the browser-based automated checker. Am I speaking sanely, and have you seen any similar problems or solutions?
Yeah, that's a great question. I think so. Like it's in a lot of those instances, the websites are using implementations that are actually failing status messages. They're failing. Like if you have the page load, DOM content loaded, event is fired, you get the page title, and then you can't navigate to anything in the page yet because it's still loading, and you don't have any NVDA announcement saying loading, something like that. That's a failure. That's a WCAG failure. So the issue that you're talking about that's present, where the page is finished loading based on an event that was fired, but the elements aren't actually ready yet, or something is not fully there, that's an accessibility issue in a lot of instances. And the best way to work around that is you hard code, like the way that we've figured out is hard coding in the element that you're waiting for. Just wait for that element to be visible and accessible and interactable. That's one way to get around it. It's still an accessibility issue though. You should still raise it as something like, oh, if the page is loaded and for all intents and purposes, the screen reader thinks that it's ready to go, and so it announces the document title, but then the page is not finished loading and there's no announcement about that, status message failure.
It seems, I fully agree, but it seems like the modern web disagrees.
Yes, single page apps are just like the bane of how everything we've built this. Yeah.
You mentioned server-side rendering very briefly, and that seems to answer 90% of the problems that I see, right? If people would just do it with PHP instead of what?
Yes.
You know what I mean?
Yeah.
Right. I'm looking for confirmation.
Yes. Oh, 100%. Yeah, like the graphic I went through was it didn't go into the in-depth implementations that the actual servers and bundled browsers and everything can do to create this website. But yeah, it would be better if things were just sent and it was all, you have it on the website and it's local, and now, and you have it on your client and it's local, and so you don't have to wait for fetch things, because then now you have to have status messages, you have to have ARIA live regions, you have to have things for these loading that you have to wait for. That's super, just adds so many accessibility issues. I don't know if I hope that that's something like React, the latest version of React is trying to really push for waterfall server-side rendering and get all of it as much as you can, and that's a good thing for accessibility. It's a good thing for general usability, like you don't want to have to wait for things to load if you can get it, loaded ahead of time.
But it's kind of funny, we had to wait for React to do what PHP was doing in 1995.
100%, 100%. Yeah, that's the way things go. It feels like.
Thank you.
Thank you. Great question. Any other questions? All right, thank you everyone for coming to the talk. I'll stick around if anyone wants to come up and ask anything. Oh, yes, yes.